All right, I'm back. 5.3, we're looking at area under a curve using the definite integral to calculate that area. And the last one on here, number 13, it's this measles pathogen function, f of t equals negative t cubed plus 20t squared plus 21t. It's used to model the development of the disease, that would be measles, where t is measured in days, and f of t represents the number of infected cells per milliliter of plasma. Determine the area under the curve on the interval between 0 and 14. Write the meaning, sketch the graph on this given scale, and shade the area. Label the axes with correct units. Now, we've done this one before, and we were looking at other pieces of information about it. Here's the function, and I sketched the graph here on the interval 0 to 25 by 5s and 0 to 1500 by 500. This is days on this axis, and this is infected cells per milliliter of plasma. So I just plotted a few points. I even got the maximum, and the maximum number of cells would be in 14 days. You have the maximum number of infected cells. So this was 14, 1,471 on that 14th day. And the implied domain, it starts at 0, this curve, and ends at 21. Because we're not going to have negative, infected cells, and we're not going to have negative days. So your implied domain is from 0 to 21. So I wrote 0 less than or equal to 21, t less than or equal to 21. You can get this from your calculator, the 21, to verify it. All I did was set that equal to 0 and solve for t. Now, let's look at this. We are supposed to calculate the integral from 0 to 14 because it wants to know what the area is on this interval. So I'm going to calculate from 0 to 14 this. So I set it up using my new skills of writing this mathematics. The integral from 0 to 14 of negative t cubed plus 20t squared plus 21t dt. Now, when I write the integral, remember this is negative t to the 4th over 4 plus 20t to the 3rd over 3 plus 21t squared over 2, now 0 to 14. I just draw a vertical line here and go 0 to 14. And then you plug in the 14 first to evaluate, sometimes called the evaluation. What do they call it? The evaluation theorem? Okay. So I'll put the 14 in. And luckily, when I put a 0 in, it wipes that out. And I put that in my calculator, and I got 10,747.3. Now, the unit on this, units are so important. The unit, when you're dealing with area, is going to be the x-axis times the y-axis, right? So if you're looking, remember when we were looking at the rectangles and looking at length times width? Well, we're doing days on the x-axis times infected cells per milliliter of plasma. Okay. Now, I would never write that as a unit. Infected cells per milliliter of plasma, and sometimes I will see that in this book. I'll write it times days. Put that. And that just means that in this number of days, that's a total number of infected cells. On the 14th day, it was 1,471 infected cells, but we're talking about an accumulation under that curve. So to write the meaning of this, so let me write this as infected cells per, that's your biology for you, milliliter of plasma times days. Now that is probably a new unit for you. Now we're supposed to write the meaning. So I'd say during the first 14 days, let's see, now we have to say there will be a total of 10,747.3 infected cells per milliliter of plasma. Now, because I'm saying during the first 14 days, that kind of takes care of the times days, so that's during the first 14 days. There will be a total, so it's an accumulation of 10,474.3 infected cells per milliliter of plasma. All right, that ends section 5.3.